Okay, so thank you for attending the security track. You've heard during the keynote multiple times that security is job zero here at Amazon Web Services. So this year at the Mumbai Summit, we've decided to have a dedicated track with multiple different sessions entirely focused on security. So throughout the day, you're going to hear from AWS security experts about things like encryption, web application firewalls, and self-defending borders. You're also going to hear from some of our partners that can help you understand their service offerings that they have in this place, in this space, to help you move to the cloud in a secure way. And you're also going to hear from some of our customers about how they have approached security and due diligence and managed their move to the cloud in a secure and compliant way. So, quick introduction, my name is Miles Hosford, and I'm a Principal Security Architect here at AWS, and I work with our customers all around the APAC region to understand how AWS approaches security, but more importantly, what you as customers can do when you move to the platform to get a more secure posture when you move to the cloud. So this first session to kick off is really a bit of a generic overview about security at AWS, and what we've taken is the most common myths or questions that we have from customers and really try to explain them in a really basic way so that you as customers have a complete understanding of the AWS security posture. So I've mentioned that security is job zero, and you'll hear that multiple times, not just in the security track, but if you go into the other sessions around artificial intelligence or big data, our story at AWS is that security should come first. It's baked into everything that we do on the platform, and we realize for you as customers to have a successful migration or to scale your usage of AWS, protecting your assets and your systems and your data is of the utmost importance. So there are really three stages of curiosity or questions that we have from our customers when we move to AWS. And the slides have changed. Can we get the slides back up, please? Let's give it a moment. There we go. So there's three stages of cloud security curiosity. And the first one is really these generic security questions that we might get. So these generic security questions are typically when customers are new to cloud, or maybe the specific teams within your organization just doesn't really understand how cloud works. So we'll start off with some questions there. Then, as your usage of AWS expands and your organization becomes more familiar with the controls that AWS offers, you may start running into some service-specific security questions. So you heard from Ollie in the keynote that we have over 125 different services. As you start using those services like S3 and AWS IAM, you might start having specific questions about security concerns of those services. And then the final really stage of questioning that I spend a lot of my time working with across the region is cloud security or cloud risk teams that have some really specific questions to data protection. So where is my data stored and who can access it? And how can I trust that AWS has these controls in place to protect my data when I use the platform? So this is going to be the journey that we'll walk through. I have maybe 3 or 4 questions or most common myths in each of these categories, and I'll work through how AWS approaches each of these. So let's get started with cloud security. So something that we hear a lot from our customers when they're new to cloud, or maybe they've just have one workload operating inside AWS, is that the public cloud cannot be as secure as their on-premise infrastructure. So customers believe that their own physical infrastructure or their own data centers can be far more secure than public clouds like AWS. So the first thing that we like to talk to customers about there is that AWS's regions and availability zones are just data centers. There's nothing unique or special about them. When we say public cloud, they are just physical data centers that are scattered around the world. And we operate all of the similar security controls that you would expect. So things like CCTV cameras at the data centers, things like locks on the doors and the server racks, security guards that operate the premises, and security managers that make sure all of these controls that we say we have do actually exist. So from a physical security perspective, we have all of the controls that you would typically associate with a data center that you currently use. Now the second thing that you get when you move to AWS that you don't really get in an on-premise environment is this idea of visibility into your environment. So let's take an example where a data center engineer or a web developer goes into your data center and they want to make some changes. So traditionally, they might sign a login book at the kind of the guardhouse or the gate, but once they're inside the data center, any further changes they make, whether they physically install a server, maybe they pull out a power supply or pull out a network cable, none of that activity will be logged. It's very, very difficult to log hardware-based changes in an on-premise world. Now, if you take that exact same example of one of your engineers or one of your members of staff making changes to AWS, so making changes to the network, maybe altering firewall rules, using encryption keys or creating databases, all of that activity would be logged. So you move away from a world where you have zero visibility into what's going on in your environment into a world where you have 100% visibility into all of the operations and activity that are being performed by your staff. So that's a great place to be, and we feel that it's bar raising and a significant improvement on normal physical security controls. Now, the third benefit that you get when comparing on-premise environments to cloud environments is this idea of automation. Because everything in AWS is an API call, the moment that a misconfiguration happens or you detect a security breach or a security incident, you can actually respond in near real time. So let's say that someone opens up, a firewall port that wasn't approved. In an on-premise world, that firewall port might be open for days, weeks, or months. Maybe you might do an annual penetration test that detects that vulnerability, but it would typically go for a long period of time. Hi. No, you can't hear me? Okay, can someone take a look? Okay, someone will take a look and change you on. Can everyone else hear me? Okay, awesome. If someone could just help this gentleman. So when you can respond in an automated fashion and actually fix things in near real time, you can go away from having long vulnerabilities exposed in your network into really fixing things in around 30 to 40 seconds. So lots of advantages there from the cloud infrastructure that you just can't get in an on-premise environment. So the second kind of myth that we hear, or a common question that comes from the customers, is that when they move their data into cloud, and you heard Ollie talking in the keynote about data lakes and data has gravity, is that when you move the data in, you actually lose your ownership. And many customers have this question. And in most cases, it's very valid for a customer to be worried about that data ownership loss. So the first thing that we discuss with customers is when you use AWS services, you sign an agreement between us and you, and that agreement commits us to making sure that your data is always yours. So any data that you move into the platform, whether it's in a database, S3, DynamoDB, or Lambda, that data is always yours legally. AWS never takes ownership of that data, and we are contractually obliged to commit that to you. The second thing from a data ownership perspective is you, as users of AWS, are in full and complete control over your logical access. So let's say that you have some sensitive data in Amazon S3, and you want to decide who in your organization has access to that. It's you that actually creates those groups and permissions and roles, and not AWS. At no point does AWS say this set of users should be able to access that production data that's yours. And that's a control that you're in full control of, and it's really empowering for a user. Now, the third one is this idea of traceability. So I've already mentioned that we have visibility into your environment on the previous slide, but what you also have in AWS is a service called CloudTrail, which monitors and logs everything that happens. And because we monitor and log in everything that happens in your environment, you can go back over periods of time and see what groups of users have actually been accessing the data. Now, if you think about an on-premise environment where you've got data maybe sitting in storage or databases, it's very difficult to keep track of who in your organization has accessed that data. If the data is encrypted, who's accessed the encryption key? How many times is that encryption or decryption key being used in your organization? Very, very difficult to know. With AWS CloudTrail, time an API activity happens in AWS, that activity is logged and stored for as long as you want, and you can go back over periods of time and find out in that data. For example, you could say today, I want to go back to 2015, and I want to see who accessed that data set on Friday, 2:33 p.m. in the afternoon. You just can't get that level of fine-grained traceability outside cloud environments. The third myth that we hear, and this is still in the kind of the generic entry-level security questions, is from highly regulated industries like financial services, insurance firms, maybe telcos, and they all think that because AWS is a service provider, they can't use us because we can't meet their existing compliance requirements. So first of all, AWS has millions of active monthly customers. You heard that Bikram mentioned this morning in the keynote. And out of those millions of active monthly customers, we actually have customers operating in the world's most highly regulated industries. Some of the world's biggest banks, healthcare providers, even government and public sector departments all run on top of AWS. So how can we support those customers run these regulated workloads if they are operating in such highly regulated environments? So the first way is via our global certification program. So AWS is certified against over 50 certifications and alignments. These include things like ISO 27001, PCI DSS, and SOC 1 and SOC 2. And we make these independent audit reports available to you as customers, so you can use them as part of your due diligence, but also use them to obtain any compliance programs that you might need. If any of you customers are processing credit card data, there's probably a requirement that you need to be PCI DSS compliant. Now, because the AWS platform has already gone through that certification, the amount of effort that you need to put in to get that certification for yourself is really been reduced. And because we've reduced that burden for you, you benefit not only from the cost optimization, so the cost associated with getting the certification, but also, and maybe more importantly, the agility and the time it takes you. If anybody has gone through a PCI or an ISO or a SOC 1 report in here, you will know that that can be quite a lengthy period of time. 3 months, 6 months, maybe 9 months. But because AWS has certified this platform for you, you can shrink that time frame down into weeks and months if required. So that's the global program. What we've also done is certify ourselves more locally and regionally. And a good example of that is here in India, AWS has gone through the empanelment process for the Ministry of IT, or MIT. We were the first global cloud provider to get empaneled, and that now allows public sector organizations here in India to select and use AWS to run their regulated and compliant workloads. So we feel that we're doing a good job from a global perspective and also a micro-regional perspective all around the world. But also, how can we take that one step further to make sure that you are covered for these compliance programs? So I've mentioned that you get a contract when you work with AWS, and we do allow people to enroll in what we call an enterprise agreement. So an enterprise agreement is a tailored agreement for you as regulated customers that gives you additional terms that helps you meet your regulatory requirements. So with a combination of global programs, regional programs, and also our enterprise agreement framework, we believe that regardless of your industry, if you're highly regulated in healthcare, finance, banking, or government, we can help you meet your requirements from a compliance perspective. So the fourth myth that we hear, again, is around data, and it's this idea of, yes, I want to use AWS, and the teams are getting excited about artificial intelligence and machine learning, but we can't use you for personal data. So we can't use you to store PII or any sensitive data like transactional or financial banking. So let's take a look at this. So when we talk about data protection at AWS, we really mean two things. First of all, access control. So you want to limit who can access your data sets, and I've discussed already that you are in full control over that. But the second real feature or preventative control that we would talk about is encryption. So one of our principles at AWS is that encryption should be made accessible and easy for everybody to use. So we've created a number of services, one of them being KMS, which you can see on the slide there. But we also have services like Amazon Certificate Manager that allows you to do encryption in transit very easily between your end users and our internet-facing endpoints, like our load balancers and like CloudFront, our content delivery network. AWS KMS integrates with over 37 of our different services. So if you're using things like S3 or EBS or Redshift, at the click of a button, AWS will go ahead and encrypt all of your sensitive data for you. Now that's a really good place to be operating, and a lot of global compliance requirements would actually require that you have encryption. But I'll ask you a question, and I don't expect anybody to answer me, is when you move into AWS, you can get encryption very easily, and I'll show you in a moment what I mean by that. But it's essentially checking a box, and we will go ahead and encrypt it for you. But what are you actually doing at the moment in your on-premise environment for encryption? And I spend a lot of the time going around APAC, talking to customers like banks and insurance firms about what their current security posture looks like. And in most cases, customers are actually not doing encryption because it's too difficult to do at scale. So when you move into AWS, you get the benefit of encryption just being made very easily at a very low cost. Now the third thing there is a number of our customers ask us, yes, we would like to use your encryption technology, but how do we trust that you can never access the key and access my encrypted data once I've moved it into the platform? So what we've done there is certify our encryption modules, or the KMS platform, with FIPS 142, which is a global cryptography certification that examines all of the controls that we have in place around our encryption hardware, and basically determines that we as AWS employees can never access the clear text encryption material that resides within our hardware. Now, FIPS 142 is a global framework. Your security teams would be well aware of what that means, and by validating our encryption modules against these global standards should give you as customers the assurance that we are doing the right things with the encryption keys, and we can't access your encrypted data once it's encrypted on the platform. So myth 5 is all around security testing and penetration testing. I have a lot of conversations with customers before they start using AWS, saying that they want to use AWS, but they can't continue to do penetration testing or vulnerability assessment when they move to the cloud. So when we talk about security testing, we really need to introduce this idea of the shared responsibility model. So when we talk about security at AWS, we as the service provider are responsible for things like the physical security. So obviously that's a control that we own. We run the data centers. We should be responsible for securing them. But as you as developers and builders start building things on the platform, you have to start making design choices around your access control or your encryption or what operating systems you want. And when you start building these platforms, we do actually give you the power to perform penetration testing and vulnerability assessment against them. Now, there's two ways that you can do that. The first way is that you go to the website and fill in this very simple questionnaire that we take and review to make sure that it's appropriate. That questionnaire captures things like the source IP address and the target IP addresses of the penetration test, and then we give you a testing window when you can go ahead and perform the penetration test. Very simple process. Millions of customers around the world are following that process today. Now, if you're operating in more of a DevOps manner or a CI/CD or a continuous development structure, you might not want to be seeking approval regularly from AWS to perform penetration testing. We might in fact be slowing you down. If you're operating in a way that you want to perform security testing every hour of the day, we really want to support that. So what we've done is launch a number of partners in our marketplace where you can launch their virtual appliances directly inside your VPC, and then once you use those pre-approved marketplace appliances, you can perform penetration testing and vulnerability assessment at any point in time. So partners like Rapid7 and Nessus and Qualys, and these tools that you probably are already using on premise, you can launch them as virtual appliances and just do penetration testing and security testing whenever you want on the platform. So those are really the cloud security questions. We're going to jump into the service security specific questions now. So I've already mentioned that you can do your own security testing. You can perform penetration testing, you can perform vulnerability assessment. AWS has no problem with that. And actually, if you speak to our security team, we would actively encourage you to be doing security testing as part of a defense in-depth security program. But when you perform the security testing, you are very likely to start identifying vulnerabilities in your applications. You maybe will scan your Windows servers or your Linux servers, and you will start identifying missing patches or missing patches at the application layer. So something that I spend a lot of time talking to customers about is understanding who's responsible for patching these systems. Some customers think that AWS is responsible for patching everything. Some customers think that they are responsible for patching everything. So let's dive into that and see kind of what's responsible there. So I've already mentioned this shared responsibility model, that we're responsible for things like the physical security and the global APIs and the global programs. But you as customers are responsible for things that you do on top of the platform. So let's say that you launched an EC2 server and you decided to launch Linux or Windows and you install an application on top of that. In that model where you are taking infrastructure from AWS, or what you would call infrastructure as a service, you as customers are fully responsible for making sure that that server is patched and up to date. When the vendors like Microsoft and the Linux repositories release their new patches maybe once a month, it is your security team's responsibility to go onto those servers and actually make sure that you're executing the commands to pull down the latest patches and apply them to the server. Now that's typically how everything works if you're using infrastructure as a service. For those of you that are using our managed services, like RDS, which is our database service that we manage, or DynamoDB or Amazon S3, AWS is actually responsible for the management and the patch management of those servers. So one of the advantages there of actually using our managed services is that AWS takes on a lot more responsibility for you in terms of management, patching, making sure the servers are secure, and that allows you as builders of the platform to just focus on building. If any of you are part of security teams or IT teams, you're probably familiar with the pain of patching hundreds of thousands of servers or tens of thousands of servers. It takes a lot of time and a lot of effort up out of your day. So if AWS can run managed services for you, which means that you no longer have to worry about patch management, we like to do that. So we do that on our responsibility. The second thing that we do is we have Amazon machine images, or basically the operating systems that you can launch in the cloud. We have an Amazon machine Linux, but we also make available things like Windows Server and Linux servers that you might want to run. Now, what we do for customers that want to run their own infrastructure and they don't want to use the managed services is when a vendor does release the patches, let's say Microsoft releases patches every month and they call that Patch Tuesday, within 5 days of Patch Tuesday, we make sure that our Amazon machine images are fully patched and made available to you as builders of the platform. So if you don't want to use our managed services and you want to run all of your own infrastructure, we put you in the best possible position to have a very healthy patch management program by using our fully latest patched Amazon machine images. The second myth I want to really bust is this idea of not being able to use AWS for sensitive data because everybody would have access to it. Now, the service that I really want to talk about there is Amazon S3. I'm not sure if you followed the news or you might have seen the news over the last 2 years from a security perspective, but every now and then there might be some incidents where an Amazon S3 bucket is exposed publicly to the internet and that bucket has sensitive data. So for those of you that don't know, Amazon S3 is our object storage that has virtually unlimited storage. You can put files in there, you can put pictures, you can put sensitive data, and customers all around the world are using Amazon S3 today. Now, by default, when you use Amazon S3 or create a bucket or a repository to store your data, that bucket is entirely private to just you who created that bucket. So that's a good place to start. Now, if you want to go out of your way and make that bucket public, and there are some use cases for that, maybe if you want to host public data, maybe you want to host digital pictures or expose a website, there are some use cases for public buckets. So when you go into the web console and actually try to make a bucket public, AWS throws up a really big orange warning saying, you are about to make this bucket public. Everybody in the world will be able to see the data in this bucket. Are you sure you want to continue? So we try to make it really obvious for customers that making that bucket public might be not the best idea. So we've got a couple of preventative controls there. Another preventative control we have is our AWS Identity and Access Management System. You can actually create an IAM policy that denies your members of staff from ever creating a public bucket in the first place. So you can create a very simple policy, attach it to all the members of your organization, and then nobody can ever do the wrong thing in the first place. So we can actually stop people creating these public buckets if that's what you want. So those are preventative controls. From a notification perspective, I've already mentioned right at the start that AWS operates in this kind of this visibility and automation that you can't get on premise. So let's say that someone does open a public bucket and they put some sensitive data in there. You can actually use our notification systems like CloudWatch events and config rules to find out about that public bucket in about 30 seconds time. So let's say that I'm a member of staff in your organization. I go into the console and I changed my Amazon S3 bucket from private to public, and that would probably be a pretty bad thing if that was left open for long periods of time. People on the internet would find it and they would find my sensitive data. Now, using our notification systems and automation, you can actually find out that I've done that in around 30 seconds and automatically remediate it by closing the bucket back to private and actually restricting my access so I can't do anything else on the platform until you've come to speak to me. Now, that's great. If you compare that to an on-premise environment where someone installs a server, installs FTP or some other file sharing program, opens up a firewall rule, and maybe dumps in a CSV file or a spreadsheet or sensitive data and exposes it to the internet, there's really no way of finding out that that's happened. It's very difficult for you in your organization to know that you have FTP facing the internet with sensitive data in. So operating in AWS, you actually get more preventative controls, and actually what I think is more important, the ability to respond and remediate in times like you've never been able to do so before. So we've got a great story there across prevent, notify, and respond for Amazon S3, and when you're looking at making public or private buckets. The next thing that I want to talk about is moving really away from data and start looking at access control. So we do hear a lot that the way that we provision secret keys or the way that cloud providers provision secret keys is not secure, and there are really easy ways of stealing people's access to AWS. So when you use AWS, there's really two ways that you can authenticate and log into the platform. The first one is via the web console, where you go to aws.com, you put your username and password in, and that's what we would call the web console login. Now, there's a very easy way to protect yourself against malware and hackers is simply enable multi-factor authentication. It's free, it's super easy to use, and it takes about 30 seconds to enable on the platform. But if you've enabled multi-factor authentication, even if I know your password, if I knew everybody's password in the room today and your username, I still wouldn't be able to log into AWS and do anything on your account. I need to come and physically steal your multi-factor authentication token from your pocket or your bag or your mobile phone. Now, without the password and the multi-factor authentication token, I simply can't do anything to your AWS account. So that's the first control. The second way of using AWS is via API calls. And if you're developers or you're operating in a DevOps manner, you're probably using what we call these secret access keys to log into the AWS environment that allows you to perform automation. Now, these access keys are typically long-standing. Once you create them once for your user, these secret access key pairs typically don't get rotated over long periods of time. And if I steal those access keys from you, it is true. I can actually then log into the environment and impersonate you as that user. So what can we do about that? So the first way to basically prevent these long-standing access keys being hacked or stolen is just to not use them in the first place. They do have some use cases, but that's very, very corner case. So what you can do is use your actual username and password on AWS, either your native one or if you're using Active Directory for federation. Then you can basically request temporary tokens. So we have a service called Simple Token Service, or STS. You can basically make a call to STS, and we will push you back temporary tokens that are time-bound for a short period of time. So even if you do lose those access tokens, maybe you checked them into your code repository and uploaded that to GitHub, and then someone found those keys on the internet, by the time someone's found those keys are no longer valid on the AWS platform. So if you are operating with static access keys at the moment, I would encourage you to move towards these temporary access tokens and certainly enable multi-factor authentication for all of your users in your accounts. So those are great controls around preventative and detective. What else do we have? So in November, just past, we launched a new service called Amazon Guard Duty. Amazon Guard Duty is basically a cyber threat intelligence platform that monitors your account and your servers, first of all from an infrastructure perspective. So let's say that there are hackers trying to break into your EC2 instances, or if hackers have already broke into your EC2 instances and now they are exfiltrating data out to the internet to maybe some dodgy countries around the world that you don't want to be operating with, Guard Duty would detect that activity and notify you as fast as possible that something suspicious is going on. Aside from the infrastructure layer, it also monitors your identity and access management patterns. So if we do detect that an access key is being leaked on the internet and it's being used from some other part of the world, we will notify you in near real time so you can take this automated response to prevent that. A good example of that, and Amazon Guard Duty, by the way, is built on top of machine learning and our artificial intelligence capabilities. After 15 days of running Amazon Guard Duty, we basically train a machine learning model on your account and your account usage. So let's say that all of your developers are logging into AWS Monday to Friday between 8 in the morning and 8 in the evening, maybe a typical working day. Now, if for some reason one of those developers or administrators logs into your platform at 3 in the morning on a Saturday night and does something that they've never done before, Amazon Guard Duty would detect that as a suspicious activity because it just doesn't make sense for your account or your environment. And we would notify you in near real time so you can go and take measures. Maybe it's an employee at your organization that is disgruntled and is trying to do something on the platform like delete your data or delete your servers, and they've never executed those high-risk API calls before. AWS would notify you as fast as we can via automated dashboard. We rate the issues high, medium, and low. And then you can take automated responses to that to actually secure your environment in really, really fast and agile manners. Amazon Guard Duty is available for entirely for free for 30 days, and there's no configuration required. So it's a click a button, turn it on. There's no appliances, no software agents, and there's nothing for you to do. So what I would say is, and encourage you to do, go back to your AWS account, turn on Guard Duty, leave it run, and see what happens. You might find some interesting findings there, and if you do, please reach out to our security team. We'd love to hear more about that. Okay, so the ninth thing that I want to talk about is this idea of data deletion. So everybody's worried, you know, when they move data into AWS, and we've already had the discussions about encryption and access control, and, you know, the customers start to get comfortable. They're worried that when they leave the platform, or when they want to delete an object, AWS doesn't actually delete it, and we keep it and use it, you know, behind the scenes for analytics or sell it to third parties. So how can we give people the assurance that we're really not doing that? So when we talk about data deletion, we really need to talk about it in really two ways: logical data deletion and physical data deletion. So for logical data deletion, it really depends on the service you are using on AWS. But it really falls down to object-based storage or block-level storage, like a disk. So let's take the block-level storage like EBS as the first example. When you go into the EC2 console and click delete EBS volume, what AWS does behind the scenes is remove that EBS volume from your account. So we detach it, you can no longer see it. It's still stored in obviously a storage pool, but what we do then, before that object is reassigned to another customer, before it's reattached to an EC2 instance and can never be read again, we basically zero the disk, or basically we overwrite the entire disk with noughts and ones, rendering any data that was on that disk previously inaccessible. Then we attach that basically random or garbage disk drive back to a new EC2 instance for usage. But at that point, your data's gone. When we talk about object-level storage like S3 or DynamoDB, when you click delete, basically the data identifier between yourself and that object gets cut immediately. So nobody then can access that object at all. It's totally prevented. So that's logical control. From a physical control, what happens when our hardware devices become end of life? So maybe our disk in our data center that your data resides on becomes end of life and we need to terminate that disk. So what we do is basically shred that disk inside the secure halls of our data centers in accordance with NIST 888, which is the global standard for media destruction. We basically blow the disk into a handful of dust. You can basically drop it on the floor and it just blows in the air like dust particles. So we basically explode it inside the data center. So from a logical perspective and a physical perspective, we have controls in place. But then the next question that customers would ask me is, Miles, those are great controls, but how do we know that you're doing that? We can't visit your data center. We can't see the storage capabilities on the back end. So how do we know that you're zeroing these disks and blowing them up inside your data centers? So if you remember, I think the first myth or the second myth was around our compliance programs. So we have things like ISO 27001, SOC 1, SOC 2, PCI DSS, and a whole bunch more. And these reports are actually performed by independent auditors. These reports aren't created by AWS. It's not me telling you that, yes, we have these controls. It's reputable third parties visit our facilities. They go through the list of all the controls that we say we have. Then they write an independent report, and they make that available to you. So if you want to go into our service called AWS Artifact, it's part of the console. You can go into the Artifact service, download these reports, and the controls that I've just mentioned there, like logical deletion and physical deletion, are highlighted by the auditors as being in place. So you can access those reports anytime you want. Now, as you start expanding your usage of AWS, many of you will start using serverless services. And serverless is a fairly new concept. It's been around now for maybe a couple of years, but it's a totally different paradigm to normal traditional IT. So when you use these serverless services, we basically only expose you to business logic, or, you know, taking Lambda as an example. You only worry about your code, you drop it into Lambda, but underneath that stack, there's a whole bunch of technology that you don't see, and AWS runs on your behalf. So there's often a concern around these serverless technologies about, you know, is my data being commingled or co-shared with other users of the platform? So when we talk about serverless services, the main control that we leave to you as part of the shared responsibility model, because we take care of everything else, is identity. So thinking about Lambda or thinking about DynamoDB, you don't have to worry about the operating system. Actually, you don't even know what operating system that's running on. You don't have to worry about the containers. And again, we don't tell you what container technology we are using to run Lambda. And the reason we do that is you don't need to know. If AWS is responsible for making sure that the serverless services works, we are responsible responsible for patching those services. We want you as builders of the platform to just go ahead and build and innovate for your customers. You don't want to be worrying about patching operating systems for serverless services. But what we do require of you is the first step of identity and making sure you provision access to those services appropriately. So let's say that you build a DynamoDB table, and that's got sensitive data in there. You don't care about the patch management, you don't care about the operating system, we take care of that. But as a customer, you do care about who can access that DynamoDB table. So maybe within your organization, you'll have a production team and a development team. Maybe you don't want the development engineers seeing the production data inside DynamoDB. So that's a control that you will still own and you will still manage. Also from an identity perspective, if you create maybe a Lambda function that has some sensitive intellectual property, maybe you've made a really cool Lambda function as part of your core application and you don't want other people in your organization or outside your organization seeing that source code. So again, you will use our identity and access management solution to limit who has access to that. Now, from a Lambda or serverless perspective, we just want to give you the assurance that it's not a totally new technology. AWS Lambda is built on top of building blocks that you are already familiar with. We have a hypervisor, which I'll come to in a moment, that runs our cloud platform. On top of the hypervisor, we run operating systems for you, or EC2 instances. On top of the EC2 instances, we will run container technology. And within that container, your Lambda functions will actually reside. So all of the controls that we have around EC2 and VPC and KMS for encryption still apply to Lambda. There's nothing different there. The final thing to mention is that when you move to serverless technologies and serverless services, is that you have a way reduced attack surface or limited attack surface. So if you think about legacy technologies, and even inside AWS, EC2 or RDS, there are still services exposed to the network. So if you launch an EC2 server and you misconfigure it, maybe you install SSH, FTP, Telnet, and a bunch of other undesirable services, that is basically exposing attack surface to the network. If you take our serverless services like Lambda, DynamoDB, Amazon S3, there are no ports exposed to the network. Actually, the network configuration is very little. We will drop an endpoint inside your VPC. You can use it, but you don't see the network traffic. You don't see that there are additional ports exposed to the network because there are none. AWS automates that deployment, and we have very little room for inconsistencies or errors when we deploy these serverless technologies. So the third part, as you move through your cloud kind of security curiosity, let's say, you start off with some generic questions, then you might move on to some specific security concerns. Really the third part comes around to sensitive data and the usage of AWS. So something that comes up a lot is AWS will pass my data to the government at any point in time. Whenever a government asks for my data, AWS will hand it over. So, AWS is a legal entity. We are based out of, based here in India. We're based all around the world. And where we operate, we do have to comply with laws, like any company in the world. Your organizations have to comply with laws. AWS has to comply with laws. But when we do receive a request for information, we make sure that it's a valid, legally and binding request. It has to be a search warrant, a subpoena. And when we receive that, we review it to make sure that it's appropriate. Amazon has a long track record of pushing back on overbroad or overreaching information requests in the protection of the customer. We do understand that privacy is important to you. We wouldn't have millions of customers on our platform running some of the most regulated workloads in the world if we were just being really, really liberal with data access requests. We also understand that these access requests are important to you. So we're really, really transparent around who's been requesting data access. So let's say a request for access does come into AWS. The first thing that we'll do, unless we are legally obliged not to do so, is notify you as a customer that some law enforcement agency has requested your data around the world. Then you can actually take action to prevent that. Maybe you can employ encryption technologies on top of your data to prevent anybody from accessing your data sets. The second thing that we do is be really, really transparent. So if you go to our website, we publish a biannual information request report that shows you how many requests of information we've actually had, but actually what's more important, out of all of those requests, how many we actually committed to. And I think you'll be really surprised with the numbers of requests is high, but the number of information sets that we've actually handed over is very, very low. And that's because we push back on these information requests. If they are overbroad or overreaching, Amazon fights it, and we've got a very, very good track record of taking a customer's data privacy first. The final thing to close on there is encryption. So as users of AWS, you are in full control over your security posture. If you want to use our encryption technologies or no encryption technologies, that's fine. But if you want to use your own encryption, maybe you have a hardware security module based on premise that you want to use. If the key resides with you as a user, the data that sits in AWS is essentially random garbage text, and nobody can do anything with it unless we visit your data center and take the key out of your hardware security module, which, if you're using a FIPS validated hardware, would be extremely difficult or impossible for anyone to ever do anyway. So there's lots of controls that you can employ to protect your data. One of the final things I want to talk about is people having a perceived threat of AWS insiders accessing their data. So with this shared responsibility model, and as AWS takes on more of that responsibility, it's really important that our customers, get the assurance that AWS is doing all the right things by them, and we don't have malicious insiders logging into your databases or logging onto your servers, accessing your data. So this shared administrative action. So first of all, we do have administrators that sometimes need to log into the platform and sometimes need to log into your systems. EC2, not so much, or actually we don't. But for things like RDS, which is a managed database service, we run the underlying operating system. You manage the database and the business logic. But for us to run the database software, we do need to log into that database and perform updates. Maybe there's been a misconfiguration, or maybe we need to adjust the backup parameters. So for us to do that, our engineers do need to log in. But the scale that we're operating at, with millions of active monthly customers, and RDS has hundreds and hundreds of thousands of customers, it's just infeasible for AWS engineers to be manually logging into databases one by one to perform updates or make adjustments or make any changes. So the very first thing that we do before we log into any sorts of software is create automation. So if we know there's a task that we need to execute on the platform, the very first thing we do is create automation to perform that task. And that automation will go and then log into the hundreds of thousands of RDS instances and perform whatever update or configuration change that we need to do. Now, when that automation fails, a lot of customers will say, well, when that automation fails, then you log into the system. And that's not actually true. What happens when the automation fails, we build automation to fix the automation. AWS is growing at a scale that Bikram was mentioning this morning, keeps increasing, and it's unfeasible for us to ever be thinking about manual processes or technology steps. So again, we use automation to fix our automation. Then there might become a point where we do genuinely need to log into the systems that you are using and operating. Amazon S3, RDS, Lambda, for example. So what do? Well, first of all, we have a lot of technology controls. So for our engineers to log into that server, first of all, they need to log into a Bastion host or a purpose-built management host. They use two-factor authentication and certificates to do that. That network is segregated from our Amazon.com network. It's entirely purpose-built management network. Once they're onto the management host that they then can log into the servers, all of their activity is logged and monitored. And for those engineers to be able to log into that management host, they need to be in the appropriate on-call group for that exact period of time. And a customer support ticket or an internal ticket like a Jira ticket must be made available before authentication will ever be allowed to happen. So we've got a lot of technology controls in place there. Also, we have a number of process controls. So the actual engineers that are part of that team all go through background checks. We've got process controls in place that make sure the activity that they run on those systems is logged, sent to our cybersecurity organization for review. Because we have so much automation at AWS, if someone does manually log into a system through these technology processes, through the management console, or through the management host, it's a very rare activity. So for us to be able to determine that someone's logged in and executed a command, it's not happening multiple times a day or hundreds of times a day. So it's very easy for us to go through the commands that were executed and make sure it was appropriate. So this combination of automation, process control, and technology will start to give our customers assurance that what we're doing on the platform with these managed services is actually really secure. So the final myth that I want to talk about is really around the hypervisor. So everything that really runs our cloud environment runs on top of hypervisor or virtualization technology, and customers will sometimes say, this is a shared environment, and I have worries that one customer, maybe this half of the room, might be able to access this half of the room's data by some misconfigurations in your hypervisor. So this is how we would typically approach that conversation. AWS, as I've mentioned a couple of times now, has millions of customers. We've been operating at this scale now for around 12 years, and we say at Amazon there is really no experience or time algorithm for experience, or compression algorithm for experience. So because we've been operating at this scale for so long, we do have the knowledge and the ability on how to run these hypervisors. And at the moment we run two variants of the hypervisor technology. The first one is Xen, XEN. I think some of you might be familiar with Xen. It's an open source hypervisor. You can go to the internet and download it. Over the last 10 years, hypervisor has been part of EC2, a core part of EC2. But what we've done is really highly modify the Xen hypervisor. So we've removed lines of code from the hypervisor. Because we've modified it to such a degree, it's actually, we remove software vulnerabilities that may have been part of the platform. And it allows our security team to be really, really intimate with the customized version of the hypervisor. AWS was also a founding member of the Xen project, so we're very close to the team that actually runs and maintains Xen. So when there is a security vulnerability, we're actually notified ahead of time before anybody else in the world, so we can actually assess the impact to AWS and our customers. And if we need to, we can actually deploy a patch with minimal or zero disruption to you as customers on the platform. So we've got lots of experience, we're part of the ecosystem, and we've made customizations. But AWS is always trying to perform innovation. So what we've done over the last kind of 3, 4, 5 years is create a new hypervisor. So EC2 has traditionally been built on Xen. Last year at reInvent we announced our Nitro hypervisor, which is basically a purpose-built hypervisor by AWS, where the components are actually removed from software and burnt into silicon hardware. So what we've done is take the management modules and operations out of the hypervisor software technology. We've burned it into the silicon hardware, and what that allows us to do is remove the chance of software-defined vulnerabilities and bugs ever being able to exist in these modules. So we've innovated there, and we've released the Nitro hypervisor. The third one is around isolation. So as a customer, the hypervisor protects you from other customers' instances. We have a purpose-built virtual private cloud technology that allows you to prevent things like MAC address spoofing or sniffing within your network, so that protects you from a network layer. And the combination of this experience, customization, innovation, and isolation really came true at the start of this year. So I'm not sure if any of you saw the Meltdown and Spectre vulnerabilities that were released on the internet. It was basically, it was an embargoed vulnerability where the research community knew about it, but a number of researchers actually released those vulnerabilities a week ahead of time. So a week before the actual scheduled launch date, those vulnerabilities were pushed out into the internet. Now, because the AWS hypervisor team has such a good relationship with the community and a fast response time, on the day that those vulnerabilities were released, the AWS fleet and infrastructure was already fully patched to 90%. And within the following 24 hours, the single remaining digit percentage of the infrastructure was fully patched, so there was no impact at all to any of our customers. So we've got a great story there from innovation around our hypervisor. So hopefully you've seen there a couple of trends from security benefits of AWS, and a lot of it went back to the global compliance program. A lot of it was talking about visibility and the visibility and insight you get, and also around our data privacy and the control and ownership you get. So just want to kind of finish with this quote. Gartner say that CIOs and CISOs really need to stop obsessing over cloud worries and start focusing their time and energy on actually leveraging the services of the cloud provider to have a more security posture in the cloud. So you've heard enough from me. Hopefully I've given you a pretty good overview of the cloud environment here.